Hi, Year 11. Tonight's lesson, I'd just like to review the 2024 final preliminary exam. So I hope you've got your exams there. So let's go through the multiple choice first. First one, which two materials will be suitable for a ship's anchor, which requires toughness, and the blade of a knife, which requires hardness and be able to hold a sharp edge? So we're looking for toughness. The anchor chain would be a low carbon steel because it's got a lot of ferrite in it and therefore it is quite tough. And the knife blade would have to have a high carbon steel because it would have to have a lot of cementite in it and perlite to provide a sharp edge. Which are the correct labels shown on the stress strain graph? This part here is the elastic limit, so that, and this right up the top here is the limit of proportionality, so that when you extend a tensile piece, it will be able to, if you extend it to the limit of proportionality, theoretically, it'll go back to where it was. So that's the elastic limit. Now, it doesn't go back totally because of the energy due to friction of the atoms. But anyway, we're just saying that's the elastic part. And as soon as it hits the limit of proportionality, all this is permanent set on the test piece. So that is the plastic area. So have a look at the elastic plastic. Now, the engineering stress curve, if you didn't know that, or the true stress curve, you have to have a look at the other alternatives, and the other alternatives don't fit. So this part here is the engineering stress curve. So you can see that the load is dropping off as it starts to neck. And this is what happens in a conventional hydraulic driven tensile tester. But what happens if you've got a computer set up to it, it's gradually recording the reduction in cross-sectional area, and so therefore the stress is going up. So this is true stress, and that is engineering stress. So A is the answer there. Which statement is correct in regards to metals that have a face-centered cubic structure? Now, you know, face-centered cubic has quite a few extra slip planes because of the density of the structure. And so face-centered cubic metals are more ductile because of their density and because of more dense slip planes. So A is the answer there. Which of the group of polymers all have a 3D cross-link structure? Acrylic is polymethyl methacrylate. That is a thermo-softening polymer. And in other words, you can, because it's only held along the chain by covalent bonds, but across the chains by secondary bonds, you can heat this up to around about 175 and then bend it. So that's a thermo-softening polymer. PVC is a thermo-softening polymer. Polyurethane is a thermo-softening polymer. Whenever you have to add a catalyst to a resin, it's almost certainly, and I don't know of any exception to this, so I'm saying almost, certainly, it's like baking a cake. You have a chemical reaction occurring and you can't do anything further to it. You can't bend it like you can with acrylic. So epoxy resin is a thermoset. Phenol formaldehyde is Bakelite, which was one of the first plastics developed in the 20s. The old radios used to be made by phenol formaldehyde, and we'll be doing it next year when we do composites in aeronautical engineering. The Nomex honeycomb between two layers of carbon epoxy layers is that honeycomb is paper, which has been impregnated with phenol formaldehyde. Polyester resin, you've got to mix the catalyst with that. And polyurethane is a thermoset. So you could sort of eliminate these because you can tell that polyethylene is a thermo-softening polymer. PVC is thermo-softening and acrylics thermo-softening. Question 5, which industrial forming process is used to manufacture this plastic chair? Now, if you're not sure of a question like this, most plastics are injection molded. So go for injection molding if you're not sure. You should know these sorts of molding processes. You should learn those and be able to draw them if you're asked to. A block of mass 100 kilograms, don't forget, mass is different to force, rests on a horizontal surface. The coefficient of friction between the two contacting surfaces is 0.3. What's the minimum horizontal force required to start the block sliding? So here we have 1,000 newtons acting down, and you've got a normal, which will be acting up, which will be 1,000 newtons. And this force, just to get it on the verge of sliding, has to equal the force of friction. Don't forget, force of friction is the interlocking of the two surfaces. It's caused by the interlocking of the two surfaces. And so the force of friction is equal to mu n, and mu is the coefficient of friction. In other words, it's a number given to the roughness of the two surfaces, and this is derived experimentally. And the normal is 1,000 newtons, so it's 300 newtons, and so that's the force required to just get it on the verge of sliding. Which is the correct statement regarding composite materials? Composite materials are a combination of two or more materials. It's not only two materials, it can be two or more materials. And so the final product takes advantage of the individual properties of the materials that have made up the composite. So B is the answer there. What are the units for potential difference in electric circuit? That's voltage is potential difference. This is resistance, that's the current flow, and that's the magnetic flux. Which statement best defines the principle of transmissibility of forces? Now, you've got to know this because we use it all the time. It says that a force will have the same effect anywhere along its line of action. So you can push it or you can pull it as long as it's along the line of action. Here we have a question on strain. So you're given a 15 by 15 metal bar. Don't forget, if there's no units there, it's always millimeters in engineering. It's 300 millimeters long. It's got a strain of 2%. Don't forget, that's a ratio. So you can't use that. You've got to divide it by 100 to get a numerical value. At failure when subject to a tensile force of 100 kilonewtons. So what's the extension in the bar at failure? So strain is equal to the change in length. Don't forget, delta is a change over the original length. Therefore, delta L equals strain over multiplied by the original length. Got to convert percentage to a numerical value. And so it works out to be 6 millimeters. Which steel can be electrically welded without prior heating? Metals, ferrous metals that have a carbon content of greater than 0.3 can be heat treated. So you really don't want to weld those because When you're welding, you can have an arc up to 5,000 degrees centigrade at the arc point. And because of that high temperature, it will cool rapidly. And if it's got a high carbon content, you'll get martensite forming because of you virtually quenching it from 5,000 degrees. And so you've got to preheat ferrous metals that are around about above 0.3%. And that's why most universal beams or structural columns that have to be welded have got a low carbon content because you don't want martensite forming in the weld pool. And so low carbon steel is the selected steel for welding that doesn't require preheating. If you're welding medium carbon steel or any of these, you've got to heat it up to above 70 degrees centigrade so that it doesn't cool as though it's being quenched. Question 12, where should a tabulated materials or parts list be placed on working drawings? Now, if you've studied the yellow book, you'll know that the title, the materials list goes adjacent to the title block. Question 13, 3 engineering components are shown below. So they're either casting, cutting, or forging. This one here is being cast. It didn't come out too well. This one here, the shape has been cut. You can see the flow lines that have actually been cut. Now this one here has been forged because a die has been pushed in there. You can see the flow lines going around the shape of the die. And this is much stronger than that or that. So, so the first one's casting, the second one's cutting, and the third one is forging. That's the answer. 2 metallic materials are bonded by pressing together their 2 rotating surfaces. And what is this joining process called? We've done that, and that, and that is mentioned, and so it's friction welding. And if you want to see what friction welding is, go to YouTube. There's plenty on friction welding, and it's used a lot in industry. What sequence accurately represents the historical progression of vehicle braking systems? So the first one was lever brakes, then drum brakes, disc brakes, and then we had regenerative braking. So C is the answer there. What's the total resistance of this electrical circuit? So you can see that these resistors are in parallel, and that one would be in series once you get the value of those 3 resistors. So remember, it's the reciprocal, 1 over R equals 1 over 2, 1 over 4, 1 over 6. So you work out what the resistance is to those 3 resistors, and don't forget to invert it. So it's 12 over 11, and then we've got to add this one because it's in series. So sigma, or sum of the resistance, equal to 12 over 11, so it works out to be 7.1 ohms. Which is the most common metal used for disc brake rotors? Now, disc brake rotors are almost universally made from grey cast iron. But the more exotic ones are made from ceramics, and the Formula ones are made from carbon fibre, epoxy, with a lot of other secret additions to the composite. Okay. During a tensile test, the sample failed with a force of 20 kilonewtons. The original diameter of the sample was 10 millimeters, and at neck, the diameter was 5 millimeters. What's the true stress? Now, the true stress is the load divided by the original sorry, the necked area, the true stress. Remember, I explained it to you that with the other stress strain diagram previously. So you write down your formula, you put your values here and make sure you use the necked diameter, which is 5 millimeters. So it's 2.5 squared. And you don't need to put 10 to the minus 6 here because your answer will be in megapascals. And so 1018.6 is the answer. Question 19, which statement is correct regarding mechanical advantage and velocity ratio of machines? You know that mechanical advantage varies with efficiency, but velocity ratio does not. So D is the answer. Which material group is the most durable for the construction of buildings? And you just have to look around. You see that ceramics are the most durable. Okay, so let's have a look at this next question. I'll just go through, explain it, then see the answer. And so you've got three forces. They all act at Z and they're all in equilibrium. So if you join these using Bose notation, you will be able to, and use an appropriate scale, you'll be able to determine the force in X and Y. So let's have a look at this. So I've used a scale of 200 equals 50 millimeters and get it down to 1 millimeter. And I've used Bose notation here. A goes between that force and that force, B between that one, and C around here. So this force is AB, that force is BC, and that force is CA. And you just draw your force diagram using that scale, and you'll get those answers. Make sure you see this here down here. Some of you didn't attempt this. Display some knowledge and understanding of the question to get 1 mark. So if you leave this blank, you've lost that mark. For example, if you just put Bose notation around here and a scale, you definitely get 1 mark. But leaving a blank will get you nothing. Okay, the next question is, here's the Sydney Harbour Bridge. I took this shot from just below the Harbour Bridge from a photograph, and you should have a look and see how they actually built this. Because it was a massive cantilever here, they had to have high tensile cables anchored down here, and in the 20s and 30s, they didn't have sufficient strong anchoring devices, so they had to build a tunnel which anchored these quite significant cables. So they went around, and one arch supported the other arch through the tunnel. So what you've got to do is find the force in this supporting cable, and you've got to find the force in this pivot bearing here. Now remember 3-force rule. You've got a force going down there, so you draw that vertically down. You've got a force going up there. Where the two join, that's a point of concurrence. And so this force will go through there, and you've got exactly the same situation where you've got 3 forces here, and you just draw a force diagram and it will close up and you'll be able to get your solution. So let's have a look at it. So this is the solution here. So there's the weight force going through the center of mass. I was pretty pleased. Quite a few of you use 3-force rule. But unfortunately, some of you just left it blank. And so you know that you produce that force on by the principle of transmissibility. You produce that force on. Where they join, there's your point of concurrence. And that's where this force in the pin will go through. So you've got your 3 forces there. Use Bose notation. So I've got A around there, B there, and C there. And just do a force diagram using a scale. Some of you got the scale wrong, and it was probably because there was quite a few zeros here. And uh, and then all you have to do then is measure that angle there, and you get the angle of the reaction in the pin. Make sure you put the point of application there, the pin, and the sense and the direction, which is shown by the angle, and again provides one correct response, which could be Bose notation. Okay, the next question. I can answer any questions at the end of this because I'm recording it. Question 21, a rivet is subject to a shear force of 100 kilonewtons. If the shear strength of the rivet material is 318.3 megapascals, determine the minimum diameter of the rivet. So if this plate goes to the left and that plate goes to the right, it will shear through pi r squared. So let's have a look at the solution here. So shear is equal to load over the area of shear, where the shear stress is 318.3 times 10 to the 6 pascals. Make sure you don't put megapascals in because you'll be a million out. And the load is 100 times 10 cubed. Some of you missed that 10 cubed newtons. And the area of shear, I just used D, so it's pi D squared on 4, which is exactly the same as pi R squared. Multiplied by 10 to the minus 6 to bring it to meters squared. You get D squared as the subject. That's a bit of mathematics for you there. So the answer here is 20 millimeters. And I was pretty pleased. Most of you got that, which is good. Okay, the next question is the orthogonal drawing given to you, and you had to do a pictorial drawing. It doesn't matter what sort of drawing you do, make sure it's got 3D in it, but I have only taught isometric, and I think it's a good idea to do isometric. I'll be showing you this again when I meet you towards the end of next term, and make sure that you draw it from this direction, because if you don't, you'll lose marks. So this is the solution there. I'll just go through a couple of things that people didn't do correctly. Some of you didn't put the curve down the bottom. Some of you didn't put the 3D holes down there. Some of you had the wrong shaped holes. Remember, there are 3 sorts of ellipses on an isometric drawing, and but generally it was done reasonably well. Okay, next question is, you've got an orthogonal and pictorial drawing of a mild steel plate as shown, and it's got a tensile force on it of 100 kilonewtons. And you've got to calculate the tensile strength of the plate if it's just going to fail. Now, you know as well as I do that it's going to fail where there's a minimum amount of metal. And it's given to you, these sizes here are given to you. So this is 50 wide, the hole is 25. So the amount of metal that's left is 50 minus 25. So it's 20, the area of failure will be 25 millimeters by 10. That's how thick it is. So let's have a look. So the tension, so you've got the load on it and the area, so that it's 25. Now I've taken the 25 diameter off the 50 width, so it's 25 times 10, and that's going to be the fracture area multiplied by 10 to the minus 6 meters squared. And so you get 400 megapascals, which was reasonably well done. Now calculate the force required to punch the 525 hole in the plate, assuming the plate has a shear strength of 250 megapascals. So punching that hole. Now the punch will punch around the circumference and then go through the thickness. So it's pi d multiplied by thickness. That's the shear area. And so you've got the area of shear. This is the important thing. So you've got pi d, which is the circumference of the circle, and the thickness. And that's exactly where the shear of the punch will actually be cutting. It doesn't cut pi r squared. A drill does that, but a punch just cuts around the circumference. And so that works out to be 196.4 kilonewtons, which is about 19 tons, equivalent to a mass of 19 tons. So it's a significant force to cut that in 10 millimeters thick metal. Describe two advantages and one disadvantage of the impact on society of the modern automobile. Now, this question I've been explaining to you all the time with describe, and also with giving spurious sentences. Like, I don't want to see a sentence like this. There are many disadvantages and a few disadvantages of a blah, blah, blah. That's irrelevant. All I want you to do is just put advantages, dash, 2 dot points, but make sure you describe. If you say, I'll show you this. If you, now I haven't described these, I've just put things, subjects that you could use in your description. For example, more stable braking. So all you do is put advantage 1 or dot point. More stable braking isn't a description, it's a statement, and you've got to put the characteristics and features. So more stable braking, which will eliminate or reduce the number of accidents as a result of skidding. So that's a description, and you've got to be aware of that. And so don't, in next year, if you're pursuing the course, don't use unnecessary sentences. Like, as I said before, there are many advantages of braking systems, and they, help society. Now, that won't be any marks derived from that. So make sure you describe it. Characteristics and features. And these are some of the things that you could describe. Okay, the next question. Now, when I did this question, I thought this is too easy, because remember, I explained to you the velocity ratio is the distance the effort moves over the distance the load moves. And with a hydraulic system, it's simple. I derived that for you, and it's not in your formula sheet, so you've got to remember that. It's big phi squared over little phi squared. It's a simple equation. And so all you have to do is put down 50 squared divided by 20 squared, and that's your velocity ratio. And it's worked on volume. So the volume moved by that piston has to equal the volume moved by that piston. So therefore, this has to move a larger distance than this one here. And that's how you derive big phi squared over little phi squared. So let's have a look at it. That's a simple solution to this question. Velocity ratio, big phi squared over little phi squared. And if you didn't get that, it's an indication that you're not either understanding the lessons or you're not watching the lessons, It's really important for you to pick up things like this and annotate your book, because that's an easy question if you know it. I mean, every question's easy if you know it, but just an easy one to remember. The next question, and if you got this one wrong and you used a different velocity ratio, a wrong velocity ratio that you used up here, you still got 4 marks for this here. So you've got to work out the mechanical advantage of the system. As you know, mechanical advantage equals efficiency times velocity ratio, and it's 85%, and you can't use a percentage. It's got to be 0.85 multiplied by 6.25, that equals 5.3, the mechanical advantage. And if, as I said, if you got this wrong up here and you use the a different incorrect velocity ratio up here, but you got your right answer there, you still got 4 marks because you can't be double penalized. Now, this is a question that was a bit disappointing because it asked you for a, left side view, and quite a few of you put the right side view here. These are a couple of things that you went wrong with. If you had these views scattered all over the place, you're battling to get half marks. They've all got to be in projection. This has to be directly above that one, so you project one off the other. With these circles here, you've got to put your center lines. Here's a circle here. A lot of you missed out these hidden detail lines here. There's your center for the circle. Make sure that you're consistent down here. See that change produces a line, and that goes across there. And I was checking to see that your projections were right. This top of the circle has to be in line with that there. And so that's an orthogonal drawing from a pictorial drawing. Okay, that's it. I hope you have a good holiday, and I'll stop the recording now, and I'll answer any questions if you want to ask me any questions. But if not, have a good holiday and have a good night. Okay, thanks, Hudson. I hope you learned a lot in year 11, but good luck with your Extension 2 maths.
Hi, sir. I just had a quick question about one of my questions.
Yeah,
For the question 21B, I was wondering, did I lose a mark because I used meganewtons units?
21B.
Yeah,
Um,
the second one.
20, oh, this one
Yeah.
here. Yeah, no, your scale was wrong.
Oh, okay.
Yeah, it had to be 100 meganewtons, and I think you only had 10 meganewtons.
All right.
But
Okay, all good.
everything else was done right.
Okay, all good.
They, yeah, you did well,
Okay, thank
A-
you.
as you can see from your mark compared to the others.
Thank you.
Yeah,
Yeah, I studied a lot on that.
yeah. Are you happy with your mark?
Yeah, I'm pretty happy. Probably I'll try to do better next time as well. So,
Yeah, I know. When if that's scaled, you would well and truly be a band six.
oh, okay. Yeah, I was wondering how engineering scales because no one really like talks about it. So like,
Yeah. Well, engineering, you know how the scaling system works.
yeah,
What happens is that each subject is uh, determined by the quality of the students in it each year. And so if you've got a bunch of good students, it scales up. So you
right.
can't compare industrial technology with engineering because industrial technology is a lot easier than engineering. So what they do is that just say 2,000 students are doing engineering each year, which is about right.
Mhm.
And so when they do their HSC, the statisticians scan the 2,000 people that have done engineering, and they scan their six subjects, and they get their mean of each subject, and then they get the mean of the six subjects, and they do that for 2,000 people, and that becomes the new mean of the subject. That's how they weight it. So you can't really tell what weighting it's going to have until that particular year. So generally, people that do physics do engineering. And so engineering is weighted about the same as physics and chemistry.
Oh, okay.
Hmm. Yeah,
So
so
is
that's how they
yeah.
weight it. What's that?
Yeah, no, because I was wondering like I'm not like 100% like sure on what like the how it's like it scales up, like what the raw mark you need to get like would be to be scaled up versus like down. That's all.
Well, you know, the mean of most exams is around about 70. The
Okay.
NESA scales up because they don't want kids getting 20%.
Yeah.
Or any student that, like for example, I've got a really weak student in my year 12 class, and if they incorporated his mark in with the rest of the kids, the mean of the class would be low, but they don't do that. They eliminate very low marks
Right.
from the scaling process. But look, I've been teaching this for a long while, and I've never seen anyone that hasn't got what they deserve in the HSC. It's
Yeah.
yeah, yeah, you work hard and you'll be rewarded.
Okay, thank you. Yeah, because I know that with my like math class, for example, it's based on what the rest of the students in my math class get. Because yeah, I was wondering if it was based on the like students in my engineering class, because I know there's not many.
No, no, no. It's based on the cohort in New South Wales.
Right, okay.
That's how it's weighted,
Right, okay.
and you can't predict what it'll be because
Yeah,
I've had some excellent classes where I've got two kids in the top 10, and uh, you know the mean of that class was 87.
wow.
But the mean of this class that I've got now will be pretty low. So you can't compare. Um,
Yeah.
all you can do is don't worry about standardizing. It's your race. You you run your race yourself, and you'll be rewarded by hard work.
Okay, thank you so much. Yeah,
Okay. Okay,
thank
well, have a
you.
good holiday. No, you're doing well, Bianca, and don't worry about things that you can't change. Just
Yeah,
yeah.
yeah,
Okay.
definitely. Thank you. Have a good
Okay.
break.
Yeah, you too. Bye.
Thank you. Bye.
Bye.